welcome back. It's Mr. M again with you on lesson number 6, common logs. So what is a common logarithm? Well, it's just a logarithm with a base of 10. And when we do this, we're going to be writing it without the base at all because it's that common, right? So we started with log base 10 of 6. We write it just as log 6, okay? Why are they so common? Well, think about it, right? If you have 10 as your base, that means you're going to end up with 10 to the power of something, right? And 10 to the power of something, we're just multiplying 10 times 10 times 10 times 10, right? So they're really actually kind of easy to work with. And because they're so common, most calculators have the common log function, which is good because we're going to learn some tricks using the common log. Okay, and even more importantly, we can solve any exponential equation because we're just going to take the common log of both sides. Before, we had to see, oh no, do we have the same base? We don't have to worry about that anymore. We're just going to take the common log. Let's look at an example of how all that works. Maybe we want to solve for x, and we're going to round to the nearest thousandth. Okay, so what we're going to do is we have 5 to the power of x equals 17. Right now, I don't know what I need to raise 5 to the power of. So what I'm going to do instead is I'm going to take the natural log, right, log base 10 of both sides. I have to remember something from lesson number 5. That would have been the power property, right? I have a power here, and my base doesn't match, so I'm going to bring that power out in front. That gives me x log of 5 equals log of 17. And if I divide by log of 5, remember how I said your calculators can handle this? Well, they can. You can type in log 17 divided by log 5 on your calculators. You can do it on Google. You can do it on Desmos app. Your iPhone calculators have it, although it's a little difficult to work with. It still works. And when you do type in log 17 over log 5, the gnomes on the inside, gremlins rather, on the inside of your calculator, it spits out 1.760. Okay, there's a problem right here for you to try. Just be careful of this x plus 1. Don't let it fool you. Take your time with it. Pause this video and resume when you're ready to check your work. Alright. We know we're going to take the log of both sides. There's no question about it. What we should notice, or what we should do rather, is use the product property. Power property. Power property. We're going to move that out to the front. So we've got x plus 1 is in front now, which means that we can divide by log 12. So x plus 1 equals log of 8 over log 12. We're going to subtract 1 from both sides to get x by itself. Depending on what kind of calculator you have, you could probably type this all straight in or do this first and then subtract 1. Anyways, how you do it, when you typed in, you should have gotten out negative 0.163. Did you get that answer? I hope you did. Common log's pretty easy, right? Let's take a look at something else we can do with common logs. It's called the change of base formula. And what this says is that for all positive a, b, and n values, a and b not equal to 1, if they give us some sort of strange base, right, not 10, let's say they give us log 6 of 5, we can change that by picking log of any base that we want, assuming that it's not 1 or negative. Right, so we started off with log a of n, and we created log b of n over a. So this is what I noticed, right? Physically written, a is lower than n. So it's going to go in the numerator, the lower part of your fraction. Physically, n is higher than a, so it's going to go in the denominator, which is physically higher. I might have switched those two. I'm sorry if I did. But you get the idea, right? It's physically higher. That's where it should be going in the fraction. As far as this b, right? The b just kind of came out of nowhere, right? It didn't tell us what b had to be. It just sort of appeared. And because it just appeared and didn't specify what it had to be, we're going to be smart and we're going to choose 10 for our base. Okay, so let's take a look at an example of how this works. I'll leave the formula up here for us for the first one. Okay, we have log base 6 of 19. We want to rewrite this so that the 19 is on top, the 16 is on bottom, and we can choose any base we want. We're going to be smart and choose base 10. So I'm going to rewrite this as log of 19 over log 6. And I can now type that into a calculator, and the gremlins do their work, and they tell us 1.643. Okay, so notice this stayed on top, this went to the bottom. I chose 10 for my base. So here's another one. Okay, again, we're just rounding to the nearest thousandth. We have log base 8 of 13. So we're going to rewrite that using log base 10. Log of 13 divided by log of 8. Type that into a calculator of some sort, and they tell us 1.233. So you have one to try on your own. You will need a calculator for this. Pause the video and resume when you're ready to check your work. All right, let's see how you did. Please, please, please tell me you chose log base 10. All right, we want log of 21 over log of 12. When you type that right into your calculator, you should have gotten 1.22, and it would have rounded up to a 5. Wow, hey, this is actually less than 10 minutes long. And I was told that if I add more entertainment to my videos, I get more viewers. So I'm going to sing for you now for the next 2 minutes. How does that sound? Alright, I'm just kidding with you. I won't do that. Instead, if you have any questions, bring them into class with you, or I guess leave them in the comment section. Any way you do it is fine with me. Can't wait to teach you the next lesson in logarithms. Till next time.